Okay, so to do these types of questions, part A is very simple. We've already been doing this. You're just writing them, putting the chemical formulas, and then balancing it. We've already done this. I don't really need to go over this again, but I guess I'm going to do it. And the charge for zinc is, go back to my polyatomic ion chart. Zinc is +2, and sulfate has a -2 charge. So that's how I know that it is ZnSO4, just like this was CuSO4. So this is already done. It's already balanced, so this one was easy. So that's what you're doing for all these. Make sure you balance them. For down here, for part B, we are seeing if this is going to replace this one. So the first one, since it's a metal, it wants to see if it's going to replace this metal. So we want to see if Na will replace Mg. So we have to look on our activity series chart and see if Na, which is sodium, is higher than, what was it? Mg, which is magnesium. So sodium, magnesium. Sodium is higher. It has a higher reactivity, a higher Riz. So that means that sodium will replace it. So our products are going to be Na with the Cl. So this has a +1 charge, this is a -1 charge. So this is how they are going to pair up. We just need one of each. And what's going to be left by itself? The magnesium. So now we have to balance this. Na is 1 on 1. There's 2 Cls here. We need another 2 here. So now I have 2 Cls. But now we put that 2 there. We have 2 Nas. So now we got to have 2 Nas over here. And now it's balanced. Let's see what one looks like that doesn't have a reaction. So like this one, Al plus LiNO3. Again, we want to see if the aluminum is going to replace the Li here. So we go on our chart. Because those are, this is aluminum's a metal, so we want to see if the metal is going to get replaced. Al is aluminum, Li is lithium. Lithium is higher. So in terms of people, this ion is already happy with Li because Li has a higher reactivity, a higher Riz. So it will not react with this aluminum. So what we're going to write here is we're going to write no reaction because it won't react. It's stable. Right, it is already satisfied with the partner that it has. So ain't no reason for it to step out and bond with something else, if you get what I'm saying. Okay, and then come down here for number 10. This one is different because this is not a metal. Chlorine is a halogen, right? So it's not going to be on this chart. It's going to be on this chart. Same rule applies. So we want to see if the chlorine is going to replace the halogen, the non-gas. Chromium's a metal. So we want to see if chlorine is going to replace the iodine, the I here. So we're going to find Cl on the chart, find I on the chart, and because chlorine is higher, yes, it will replace it. So now we're going to write over here, we're going to write CrCl, and the charge for this Cr was 3 because there were 3 iodines here. So we know that the Cr had a +3 charge, and the Cl has a -1 charge. So now you put them together to get your formula for CrCl3, plus what's going to be left by itself? Iodine is being kicked to the curb, and so iodine plus iodine, and it's going to be diatomic, so plus I2. So I don't want to write it because that's just way too easy, but yes, there you go.